hard. We're back on the chapter review, page 2021. Last time we started 13, I kind of rushed it. I cut it off in the middle because I was making a mistake of trying to take a radical and turn it into a 7 for the exponent for the bottom y, which got really weird. So kind of omit or overlook everything you just saw on number 13, and we're going to start over. Division. Division can be made as a fraction bar, so we're going to rewrite this as a fraction. So we're going to have 28x to the 5th y squared divided by, there's our fraction bar, 7x cubed y square root of 5, and on the top I lost my square root of 15. So there we have all of it. All right. Now, the rules for this are on page 5. And what it says is for a fraction you do what? Reduce the numbers and reduce the names. Excellent. And then in parentheses it says to divide with like bases you subtract the exponents. That means we're going to do our x's with our x's and our y's with our y's. We're going to do numbers with numbers and radicals with radicals. We divide our like stuff out. Now, when you do 28 divided by 7, you get 28 divided by 7 is a 4. Now, if I make a fraction bar, the 4 is going to go on top because the bigger number was on top. And then I get to my x's. When you divide with like bases, you subtract the exponents. The difference in the number of x's is 2. So here we are in slow motion. Make sure everybody gets it. To divide with like bases, you subtract. The fancy word for subtract is difference. They have a difference of 2, and there were more where? On top. And so we put the x squared on top because that's where there were more at. Everybody understand that? And then we're going to do our y's in slow motion. When you divide with like bases, we have y squared divided by y to the what? Understood on the bottom? To the first. When you divide with like bases, you, and the fancy word for subtract is difference. There's a difference of 1. There was more where? On the top. So we put our y to the first, understood, on top. And then we get to the radicals. Square root of 15 divide square root of 5 is square root of, and the bigger was on, so it goes on top. Now what's on the bottom? 4 over 1. What's x to the 5th divided by x cubed? X to second. Now that's what happened right here, right? Now what happened on the bottom right there? X cubed divided by itself. That's what happened on bottom, right? We're really reducing. When you reduce, you divide the top and bottom by the same thing. If we divided the top, x to the 5th divided by x to the 3rd, we had to divide the bottom by it also. When we divided the top by it, we got x squared. When you divide the bottom by it, you got a 1. So actually you have another 1. And right here we divided y by its y squared by y to the first, and we got y to the first on top. On bottom we really divided y by y and got another 1. On the radicals we divided by the greatest common radical factor 5. On the top we got square root of 3, and on the bottom we got another 1. And 1 times 1 times 1 times 1 is 1. And we don't need all that 1 denominator stuff, so it's just 4x squared y cubed. Oops, 4x squared y square root of 3, sorry. But see how we did that? Yes. Got it? So everybody understands we did that, and we said there's two more on top, but we need to understand that there wasn't nothing on bottom. There was a 1 on bottom, because we really divided the top and bottom by the biggest thing that'll go into y and y squared, the greatest common factor. Any questions on number 13? Okay. Number 14. What does it say on page 5, division? The first thing it says on page 5. You got multiplication on the top half of the rules. You got division on the bottom half of the rules. It says to divide, use special rules. And then it says reduce the numbers, reduce the names. When you divide with like bases, you subtract the exponents. Where are those special rules we're talking about on page 5? They're on page 7. Go look at page 7. There's the special rules it was talking about on page 5. On page 7 it says to divide by a decimal u. Move it over enough places in divisors so that the big divisor becomes the whole number, same number of places in the dividend. To divide by a fraction, this is page 7, the second rule. To divide by a fraction, you reciprocate it and multiply. Did that have anything to do with the 3/5? And what else do we have to be aware of? The negative sign. Where do you put your negative at? On the top or in the middle, but we don't put it on the bottom. Don't lose your sign. When you reciprocate, does it change from negative to positive? No, it stays the same sign. Now we're going to multiply. To multiply, you multiply the numbers. And when you multiply, this is a positive and when you multiply or divide with different signs, the answer is negative. When you multiply with different signs, the answer is negative. Over, you multiply names and you get a new name, so we get negative 18/25. We should see if it'll reduce, but it won't. Any questions on number 14? So all the rules are there. You just have to say them, think through them, follow the rules, and you got it. All right? Everybody done with number 14? Number 15, the operation is subtraction. To add or subtract has to be true. Names have to be the same. In algebra, we call them like terms. With fractions, we say that we need to find the common denominator. To find the common denominator, you find the least common multiple. So we're going to align these knowing that we need a common denominator. And we're going to go through the drill of finding a common denominator. The common denominator is the least common multiple. To find the least common multiple, you do the prime factorization and you write them as exponents. So 5 is just 5 to the first. 7 is just 7 to the first. Then you take the largest power of each prime and multiply, and that's your common denominator. So my common denominator is 35ths. Then we convert our numerators, which we call making equivalent fractions. Good. So we think 5 times what will give me that 35? 7, so negative 3 times 7 is negative 21. Remember, we have to use sign rules. The sign of the 3 was negative. The sign of the 7 was positive. When you multiply or divide with different signs, the answer is negative. We're still having to think sign rules every little step of every little problem. And then we think, okay, 7 times what is 35? 5. So 2 times 5 is 10. Now we got to be careful. That was a minus, so we keep our minus, or if you put the negative up on the 2, that would make it a negative 10. But we know that minus 10 is negative 10 either way, so we realize what's going on in the background. Now this is one that people mess up a lot on because you let your guard down right here. They're going to say 21 minus 10, 11. Your little brain is going to say 11 whether you want it to or not. But what happens when you add or subtract? The names stay the same 35ths. If you let your guard down after all that work and you see in your mind 21 minus 10, your brain's going to say 11, but we don't do math that way. We say our signs, right? We take the time to think them and we take our time to write them down. What is the sign of the 21? What is the sign of the 10? It's negative, because we learned that we have to carry the plus or minus as a sign, and we learned that a minus 10 is a negative 10. And when we get it out of the context of a sideways problem, like we saw it on page 18, we start missing those little pieces. The signs are the same. When you add or subtract with the same sign, you add them. And take the common sign, which was negative. And so we have negative 31/35. We have to be real careful with our signs when we get them infiltrated in a bunch of other stuff, like getting common denominators and doing big, long algebra problems. Don't forget to stop and think through your signs. Got my tongue a little bit lit. Any questions on number 15? Yes, sir. Okay, so the question is, how do we know if it's positive or negative? And I want to go back and show you something else. First of all, let's just take this and blow it up. We said we got 3 choices. That's either negative 2 divide negative 7, it's 2 divide negative 7, or it's negative 2 divide 7. That means one of those 3 things, right? Now, can it mean the first one? When you divide with the same sign, the answer is positive, but it's supposed to be negative, so it can't go on both of them. It can only go on one of them, because when you divide with different signs, it's negative. When you divide with different signs, it's negative. So either one of those, it could be a negative. It could be either one of those because it gives you a negative answer. But one of them we don't like. Which one do we not like? We don't like that one because we call that the name. It's the denomination or the denominator. So we don't allow negatives in the denominator, so we make it that one. So if you have minus 2/7, then it's really a negative 2/7, because minus makes it negative and it goes on the numerator. That answer that question? Any other questions? Okay. Number 16. Number 16 is just like number 15, isn't it? To add or subtract, what has to be true? Names have to be the same. To add or subtract, the names have to be the same. In algebra, we call them, with fractions, we say that we need a, do we put in simplest form if it's a fraction? No. We have to find a common denominator. You don't put in simplest form, you find a common denominator. Now, if it didn't have denominators, it was just x plus m, we'd put in simplest form, but it has denominators, so we have to find a common denominator. How do you find a common denominator? LCM, least common multiple. So we're going to have to find a common denominator, and we're going to do that by running the LCM drill just like we did on number 15. So, to find the least common multiple, you do the prime factorization. And we do the numbers and then we attach the variables to it, right? And you can see that happening on page 8 of the text. I guess I should probably go there really fast. Let's go to that. Student edition, page 8. That's 18. You can see if we follow from the top, adding and subtracting fractions, unlike fractions. Rule, you must get a common denominator. The common denominator will be the least common multiple. B, to find the least common multiple, B, you do the prime factorization. You take the largest power of each prime and multiply. C, and if you look at example 2, you can see that we did the prime factorization with the numbers, and then we attach the letters. That's not going to go where I want it to. I knew that. See, we took the prime factorization of the numbers, and then we attached to the end of that the variables, and so there was the process. Now what if there's not any numbers? Then you just put the letters. What if there's not any letters? You just put numbers. What if there's both? You put them both. All right, back to the lesson. We need a common denominator. To find the common denominator, we find the least common multiple. To find the least common multiple, we do the prime factorization. If there's numbers and letters, we put both. If there's numbers only, we put numbers only. If there's letters only, we put letters only. G times H, or H times G. So we're going to have H to the first times G to the first. We wrote them exponentially. Now what do? Take the largest power of each and multiply. The largest power of Q is Q to the first. Largest power of H, H to the first. Largest power of G is G to the first. You multiply those, you get QHG for a common denominator. Understand that on number 16. So my common denominator is QHG. And I convert my numerators over the exact same way I did with my regular numbers. And when we convert the numerators, we're saying that we are finding equivalent fractions. And so we think Q times what will give me that QHG? HG, the missing stuff. So I multiply the top by HG and I get XHG. You understand that? Same thing on the bottom. HG times what will give me QHG? Q. So I multiply the top by Q and I get M times Q is MQ. So we made equivalent fractions. Let's see how we got that. Now, when you add or subtract, the name has to be the same, and when you get done, the name stays. That was weird. The name stays the same, QHG. And then we're going to add our numerators, XHG plus MQ. Now, can you combine XHGs to MQs? No. So the numerator is written out as an expression, XHG plus MQ over the common denominator, QHG. Any questions on number 16? How do we get that? We ran the drill exactly like we did the numbers. It's all a bunch of words, isn't it? I have a nephew that when his little kids are fussing with one another, he says to them, use your words. Don't use your fists, use your words. And it's our words that gets us out of a jam in algebra, you see. Don't fight it. It won't do any good. People fight algebra. They hate it. They fight it. They talk bad about it. They use ugly words about it. they quit on it. But if you use the words, and when I'm saying words, I'm talking about rules. If you use your words, it's going to work out. Okay? So I always think about my nephew telling those little girls and that little boy, use your words. Use your words. All right, any questions on number 16? I'm a great uncle. I have 8 great nieces and nephews, which is pretty great. Anyway, any questions on number 16? That means I'm old, doesn't it? Number 17, multiply. What do we have to do to multiply mixed numerals? Change them to improper fractions. It says that on page 11, right? To multiply, divide mixed numerals, change them to improper fractions. Why? How come we didn't do that when we added or subtracted? Let me show you something. Could you? Somebody asked that the other day. I think it's on this tape when they ask it. I could take that and multiply by 3 and make it 18 feet. And I could add 2 to that and make it 20 feet. And I could multiply that by 12 and get 240 inches, And I could add that to the 9 and I could make it 249 inches. Now what did I just do? I made it improper. I turned it all into inches. Is that the easiest way to do that? To turn all of these into inches and then turn all of these into inches and then add and then turn it all back into the other stuff? No, it's easier to do what I said on page 2. Put your like terms together and combine them. We didn't make this improper either. We could have. But would it made our job easier or harder? Harder. It was easier to put our like terms together and combine them than it was to convert them into one name and then add and then convert it all the way back out. But with multiplication and division, we make them improper. Why? Because the rule says you multiply the numbers and you multiply and the numbers are the numerators and the names are the denominators, so we don't have any choice. Unless you know how to do page 200 and do the full method, where you go -3 times 5 is -15, and then you go -5 times 3 3/5 is going to be, or -5 times 3/5 is going to be a -3, and then you go 2/7 times 3 is 6/7, and then you go 2/7 times 3/5 is 6/35, and then you get a common denominator 35, and that makes that a 30, and then you have 36/35, and you have a -18, and that's a 1 in the 35th, and so it's going to get messy, you see. That's not the easiest way to do it, even if you knew, because there's some sign rules in there that I didn't throw in there. I was just doing that real quick to show you. There's 4 multiplications that have to happen. You would have to, if I do that in slow motion, say -5 times the 3. And then -5 times the other one 3/5. And then 2/7 times the 3. And then 2/7 times the 3/5. Now here's what people do, and I get to you in just a second. People that do this wrong, they multiply these and put -15. And then they multiply those and they put 6/35. And they call that the answer, and that doesn't work, because how many multiplications did you do if you did that? 1, 2, and you cram them together, and they're supposed to be 1, 2, 3, 4 multiplications, and you can see page 200 and see what I'm talking about right here. So don't be trying to multiply the whole numbers and then multiplying the fractions, because you won't get the right answer. That's what everybody does wrong. Question? You will when we get to page 200, but right now you don't. All right. So my point is this. You don't just multiply the whole numbers and then multiply the fractions. You leave out some stuff. We have to, as far as you know today, make them improper and then multiply. Now here's another thing that we've got to think about. When you make this improper, don't be looking at that negative sign. People will go 5 times negative 7 is negative 35 plus 2 is negative 33. Forget the negative sign is there. Cover it up and then multiply. 5 times 7 is 35 plus 2 is 37, and then put the sign back on it. You understand that? And then on this one, 3 times 5 is 15 plus 3 is 18 over 5, and you multiply. Now you can cross-reduce if anything will cross-reduce, but it won't, so now you multiply. You multiply the numbers, and you're going to get 370, this one's hard for me, 370, 824, 610, 666. And when you multiply, this is a negative, and this is a positive. When you multiply with different signs, the answer is negative. And then you multiply the names, and you get 35ths. That will not reduce, so it's negative 666 35ths, and you can leave it improper. Any questions on number 7? Yes, sir.
7 times negative 5, wouldn't that be negative 35?
But that's not a negative 5. Oh, you're saying right here.
Yeah.
Okay, here was the question. Is it 7 times negative 5 plus 2? Isn't that negative 35 plus 2, which is negative 33, instead of negative 37? And what we said was this. We want to act like that negative sign wasn't there. We're going to omit the negative sign. And we're going to say 7 times 5 without the negative is 35, plus 2 is 37, and then we're going to put the negative back on it. Yeah. I'm glad you asked that again, because you might not have been the only one that didn't catch that the first time. So cover up the negative sign when you change it to improper, and then put it back. Any questions on number 17? Number 18 is memory work from page what? 13. Anything raised to the 0 power is 1. What's q to the 0? 1. What's x to the 0? What's 2 to the 0? What's 0 to 0? We better talk about that one. 0 to the 0. I taught you something way back yonder on page 13, and I want to show you this because I want to teach you the math. This is going to lead to something in chapter 4, and I want to start drilling it in your head before we get there. So there's a reason I'm doing that. Is it 1 or is it 0 or what is it? That's kind of a weird one, isn't it? Well, let's go to page 13. There's got to be a rule that's going to help us out if we get there without running over it. I need to go to the student edition. Excuse me, student edition, page 13. That's page 8. Now here's what we talked about on that page. We said that 3 squared means 3 times itself, and the answer is 9. Now you can take a calculator and you can program that in there, right? Make it say, if that's a 2, then we're going to make the calculator say 3 times 3. 3 times itself twice. We can program that. Now, 3 to the first, we can't tell the calculator to say 3 times itself, and we can't make it say 3 times 1, because that's not what's going on. Remember when we studied this? How would the calculator have to be programmed? It would have to be programmed, if you want to do it right, to take 3 to the second and then divide that answer by 3, because that's really what gave us the 3. It's not 3 times 1. It's not 3 times itself. It's the previous answer, 9, divided by 3. If you wanted to program it properly, that's what you would have to do. Now, if we're going to continue this scheme the way I taught you, then if we subtract 1 from the exponent, we would have to take the previous answer, 3 divided by itself, 3, and 3 divided by 3 is 1. Now, no matter if you program that with 3's or 4's or x's or q's or y's or zeros, how are we going to get that 1? We're going to take that number, which is itself to the first power, and we're going to divide it by itself. That's why it's 1 every time. 3 to the first is the number. To go down 1, you divide by the number, and anything divided by itself is 1. That's why to the 0 power is 1. That makes sense? So let's say this was a 0 to the second power. That would mean 0 times itself. And then 0 to the first power would give you that number 0. Now, if I wanted to go down 1 more, what's the only way the calculator can be programmed? To take this answer, 0, and divide it by 0. Can you divide by 0? You cannot. Division by 0 is mathematically undefined. I'll prove it. Let's say that we had, I X'd that guy out. Let me go back to my calculator. I didn't minimize it, I X'd it. Let's say I had 5 divided by 0. It's impossible. Division by 0 is undefined. Let's say I had 7 divided by 0. Can't do it. Division by 0 is undefined. What if I had 0 divided by 0? Can't do it. Now, if I'm going to take 0 raised to the 0, I'm going to have to take my previous answer, 0, and divide it by itself, 0, and so I'm right back to 0 divided by 0. Is undefined, but this time it didn't say undefined, it said there's an error in the domain. So we can argue the rest of our life, which is useless, as to whether 0 to the 0 is 1, or it's undefined, or what. I suggest that it's undefined because the 1 came from something divided by itself. And division by 0 is mathematically undefined, so I would be one that would argue that 0 to the 0 is an undefined concept in mathematics. But anyway, that was free. Yes? Right. 3 divided by 3 was 1, but 0 divided by 0 can't be done. Division by 0 is mathematically undefined. You know why? I'll explain why. Let me clear that out. If I have 3 times 2 is 6, and then I take 6 divided by 2 is 3. What does it mean about the 2 and the 3? You can multiply them to get 6. So if I take 6 divided by 0, what's the answer? If it's 0, then what that means is that 0 times 0 is equal to 6. 0 times 0 is not equal to 6. Is there any number that you can multiply to 0 and get 6? So can you divide by 0 and get an answer? Division by 0 is undefined. You can't get an answer, but you can multiply back to 0 and get what you started with. Now you might say, oh, let's go back to that 0 thing. What's 0 times 0? So maybe it is 0. Or maybe it's undefined because division by 0 is undefined. But who knows? You know, it's not worth arguing about. There's different ways of looking at it in there. There's a lot of math. This is just one of those little things. I don't know why I did this, but I thought it was kind of nice. Oh well. So, why did we say all of that? We said all of that because we were working on the review. And we were over here talking about on the review, and I hit the wrong button again. I need to be on the transparency, I thought. I do, but I'm just not on the right page now. We wanted to be on page 20 of the review, 21. And we were looking at example 18, and we said anything to the 0 power is 1, and that's true, but we're not sure about 0. It might be 0 because 0 times 0 is 0, but division by 0 is undefined, so we don't really know what to call it. Everything else, if it's to the 0 power, it's 1, we know. All right, half power. What does the half power mean? Square root. So half power means square root, so 25 to the half means square root of 25. Understand that? And what does square root mean? What times itself equal? And if it didn't just hit you what it is, what would you do to find out? It actually tells you on page 15 and 16. You do the prime factorization, and you would see that it is 5 times itself. That gives you 25. Any questions on number 19? What if you put the answer square root of 25? Would that be okay? No, because what's the directions for this test? Simplify. Simplify. And that's not simplified. 5 is simplified. Any questions on number 19? Now number 20 takes us to page 15 and 16 where we're doing a big simplifying, a radical. And on page 15 it's got step 1, 2, 3, 4, 5, 6 in the form of A, B, C, D, E, and on page 16 it's got the example of how to do it. So to simplify a radical, what do you do first? Prime factorization. So we take the 540 divided by 2 is 270, divided by 2 is 135, 5 and 3 is 8 and 1 is 9, so 3 will go into that 45. That's divisible by 3, 15, divisible by 3, 5. We got a prime answer, and so we stopped. Got worse. And so then we write it out as the product of its primes under the radical sign, not forgetting our index 3. So we have 2 times 2 times 3 times 3 times 3 times 5. There's all of our prime factors. Factors, what's a factor? It's what you use to multiply to get something. Now what does it say to do? For cube root, circle sets of 3. For square root, circle sets of 2. Cube root, sets of 3. Fourth root, sets of 4. Now what does it say to do? Put 1 from each set outside. Not all 3 of them, only 1 from the set. And then you take what didn't get circled and put it back in. I'm saying it just like it says it on page 15. And then you multiply the outsides. There's only 1 there, 3. And a 5. Thank you. There's another 5 in there. So the 5 didn't get circled. It goes back in. We multiply the outsides, multiply the insides. 2 times 2 is 4 times 5 is 20. And so we get 3 cube roots of 20. Any questions on any of that? How many questions is the chapter review at the end of chapter 1? 20. How many questions will be on the chapter 1 test? 20. What are they going to look like? These 20. What order are they in? Same order. How do you know you're ready for the test? When you study. When you can do every one of these without looking back at your notes or getting help, right? So you need to do this in the post-test study pack enough times that you can work every single problem on both of them with no help and not looking back. And you should be able to say the rules as you do every one of them. Now, if you can do that, you're good. And you're going to be successful. Let me shut this off.